So today we're going to discuss about the EV structure. So for last few weeks, we already talked about the EV component, the control, everything about the background. But EV teaching is not only about the vehicle itself. EV is affecting the whole system, how the city planning, how the vehicle connect to the grid, and all the issues related to EV. So that's why this chapter, we're going to look into how the whole infrastructure look like, how the EV will be a very important player for the whole structure. So today we're going to show you about basic reviews of the charger and how the charger relate to the load management system and what's meaningful vehicle to grid and how about the payment system and also the power issue related to the EV. So firstly, I'll ask you a few questions. So what do you think if the EV will affect the city development? We all know that it must have some effect. So anybody can tell me, what do you think? What kind of example of the EV can impact to the city development? Could you say something?
If we there are more EV in the city, there need more the charging station in the city development. So that will have some influence on the power grid in the city. And we also need some for the advantage, I think there will be less traditional vehicles in the city.
So that means you can see that there will be changes in the power grid and also maybe the charging station, maybe the gas station. Probably will also changing the traffic control, which we may not cover here. But when we have more electric vehicle, maybe, and then we have more autonomous vehicle, then the traffic control could be quite different. Vehicle can talk to each other. So that's why I come into the V to X. X means everything. So the vehicle can be talked to other vehicle. Then in this case, you can promote all the traffic control, can reduce the traffic jam. Probably some communication between them can be achieved. You can see that if you have two vehicles, one in the front, one in the back, the back vehicle may not able to see the traffic in front of it. But if the front vehicle can able to communicate to other vehicles, tell them what's happening in the front end, then in this case, all the traffic will be much more controllable, and all the vehicle can know what happened for the whole network. So that's what we're trying to do. We're going to have a more electric vehicle. They're all able to communicate to each other like V to V. So once we do that, then everything will become more perfect. That will be really wonderful development for the city planning. Another thing will be for the charging. You can see that we need to think about how we're going to charge the multiple vehicle. We have many vehicles. How are we going to charge them? For instance, if we don't have sufficient power, how are we going to provide the power to each vehicle themselves? Another thing we can see that we are going to use the load management. Load management is mainly to see if you don't have sufficient power, how are we going to manage the load? Which one have higher priority? Which one have lower priority? Would that be using first come, first serve, or whatever method you can think of? So load management is still a new topic. We need to look into how we control the load for multiple users. Another issue will be opportunity charging. Opportunity charging, anybody can tell me what's meaning for opportunity charging? So that means wherever there's opportunity, we charge the vehicle. So that's to say, most of the time, our vehicle, when we park in the parking lot, in a garage, we start to charge. And however, opportunity charging will be more useful for some commercial vehicle, like the buses. Then whenever in the parking, bus stop, or in the terminal, they will charge them. In this case, they can have more opportunity, more time to charge, rather than charge them once a day or twice a day. Because if the vehicle only, especially for public transport, you only charge once a day, twice a day. In this case, you need to allocate a specific time for the charging. In this case, because the commercial vehicle mainly for business, they don't quite happy about allocate 1 hour for charging, maybe 2 hours to charge. So because that affect the business. So he was able to use opportunity charging like in any traffic light or maybe bus stop, they can charge a vehicle maybe only for a few minutes. But if you're adding all the multiple many a few minutes, then still will be a good amount of time for charging. So and then we're also looking into in the future how we're going to convert all the vehicles to electric. So today we started to have more new vehicles in electric. I think in many cities, not only in US, many other cities, I think the new registration for vehicle could be nearly half of them are electric. So that to say, people will see this issue. So we're going to see that there will be more electric vehicle, meaning about the cost will be much better. The government has some incentive or maybe additional benefit to the EV user. And what issue will be happening if we want to convert more vehicle to EV? So we think about that. What is the short-term and long-term issue we look into? So in here, in this chapter, we're looking into the whole city development about the infrastructure, more in the system point of view rather than in the component point of view. So today we're going to go for a number of sections, a chapter. So we also briefly talk about the charging types, and then we also talk about the vehicle to grid. So that's really important, especially for infrastructure. About the load management, how we're going to manage the load, and the battery swapping is another new method, not really new method, another method we're able to shorten the charging time. You see, for battery swapping, probably just a few minutes. You can swap the battery, become fully charged battery, instead of using 1 hour or 2 hours, half an hour. So there's many people talking about it. We also talked about it last week. So today we're going to discuss more detail about what it is. We're also looking into the dynamic charging. Dynamic charging, that means we charge the vehicle when the vehicle is moving. So that's rather than stationary charging. So there could be many research topics examine that. And then we also talk about the payment method. There's many payment methods in here, introduce a few of them. So, but today there's a million of the charge payment method. And the opportunity charging is also really important for city development. And then now next we're talking about the overall city development for related to city planning. And then we conclude. So firstly, we know that I think we also discussed for last few lecture. Basically, we got the level 1 charging, which is mainly about low voltage, 120 or 110. That will be so-called level 1 charging. So usually it will be household charging. Then we have any power point in the socket in the wall. Then we can use it to charge our vehicle. That's commonly available for most of the garage. You can do that. But nobody was satisfied with level 1 charging because it's too slow. Probably you need to charge it for 2 days vehicle. You may need to end up with maybe more than 1 day, more than 2 days to charge it. So that's why we come into level 2 charging. Usually we use higher voltage, for instance, like the 208 voltage level. So in this case, we're able to provide high power for charging. That can be single phase, that can be 3-phase. It all depends on your power source. But once we go up to more than 200 volts, then we call it level 2. So most of the onboard charger for vehicle or AC charger you're out there, like the IEC Type 1, usually they are the level 2 charger. So that's more widely available. I usually talk to the government saying that if you don't have sufficient high power charger, supercharger, we can install more of a level 2. The level 2 charger, the power level, as we mentioned, roughly about in average about 11 kW. That will be really comfortable by many parking lot, so they can able to provide that. Only 11 kW. Meanwhile, the supercharger 200 kW is really impossible, right, to provide huge power. But 11 kV, I mean, many households you can able to afford to supply you 11 kV or many parking lot that will be really feasible. So that's the thing we look into. And then for level 3, usually for high power, maybe the DC charger. Then we have a number of technology like the ChargeMode, DC fast charging. You can see they mainly about high power using DC connector. We don't have specific definition for level 3, but usually anything more than 60 kW power will like that can go up to anything. Today, some of the ChargeMode charger can go up to 400 kW. Even though supercharger will be 255, right? So that's why we see that And this is three major things we're going to implement in the city. But of course, level 1 will be really low cost because only simple single-phase power plant. Level 2 slightly more expensive, but they still an AC connection. As I mentioned last week, level 2 charger is not really a charger, only an AC wiring connection with some kind of indicator. And then level 3 is really a charger because they really need to regulate the current, regulate the voltage, provide you the charging current in form of DC. That DC can directly connect to your battery. So level 3 is really the charger. So that's why level 3 charger is more expensive, much more expensive. So that means for city development, we're not able to implement that many level 3 charger, maybe only a small portion. Usually only maybe a few percent, 10%. Of course, all the public, they like the government, they like the city to implement more level 3 charger, but the main reason is the cost and also the power. The power company may not have sufficient power in each of the district. So usually only have a few installation. But level 1, level 2 could be really much feasible. And they're not expensive anyway. So like, for example, like Tesla supercharger is mainly DC charging system. You can click the link, you can see more detail about the supercharger. I think they already implement version 2 and version 3. Like the version 3, they are really high power, can go up to 250 kW. I mean, you can see that the data here, they are able to charge most of the Tesla vehicle. For instance, from 9% to 90% SOC can complete within 35 minutes. So that's quite nice. So that means usually your vehicle, you can go in there within 30 minutes, you can finish charging. The thing is, most of the vehicle, including Tesla, they won't set the maximum SOC to be 90 or 100% because that's not good for a vehicle. You usually set that 80% or by default will be 80%. So if you want to charge a vehicle up to 80%, usually less than 30 minutes will be more than enough. Unless you go for a long trip, then you need to charge up to 100%. But you don't do it that often. So you can see that each 1 minute you can top up by 10 miles. So that's quite nice to have, right? So that's how the level 3 charger now they look like. And then Tesla has implemented many of these level 3 charger. But however, for city development, the government only install level 2 charger using IEC 62193. Type 1, that would be many. But type 2 don't have that many. But mainly will be dominant by Tesla level 3 charger. So for domestic, our home, our garage, our parking lot, we usually implement our own level 1 and level 2. So we can do that quite easily. If you go to Amazon, go to eBay, you're able to buy any one of them. Usually they're really low cost. Talking about just from $300, you can get one. If you try to ship it from Asia, then can even cheaper, can be less than $100. You can get one. Because as I said, they're only a wiring connection with a box, with an indicator, with a plug. So they're supposed to be really low cost. But having said that, if you want to install them, you need to install the RCD. So it's so-called the ground fault circuit interrogator. So this kind of thing, I think all your house have that anyway. That mainly about the safety. You need to have that kind of protection. So nowadays you can see outside there in our parking lot, we also see quite a few of these. They're also using about level 1 or mainly about level 2. They also have this kind of the earth rock protection. Then all the public charger system, they mainly about AC input. They seldom have a DC input unless the supercharger. So that means they are only level 1 or level 2. So I mean since they are level 1 or 2 charger, many of users they still demand for the payment. So the payment method is vary among each of the company. So sometimes they got the kiosk somewhere. You need to select how you're going to charge it and how to pay them, which parking lot you park your vehicle for charging, and then you submit your payment. And then this kind of the HELOC will able to control a number of the parking lot. So of course, some of them, they don't care, they don't charge you. But today, most of the charger system, they start to charge you. So all of them, they are for the DC charging system, the internal voltage can be vary from 45 up to 500. And then inside there, they got the charging mode from CC, CV, and pulse charging system. They also have communication from their connection to communicate between your vehicle and also the charging station to tell a number of parameters, including temperature and voltage and current. So that parameter will control how much current you're going to charge it. So that means don't think about the power to charge vehicle will be fixed power. The edge variable power that will be controlled by your BMS or VCU of your vehicle. They will communicate to do that. So each of connection, we do have the proximity detection, make sure they connect properly, so you cannot unplug it when you're doing the charging. Sometimes they will recognize if you are the user, you may need to key in. Sometimes you need to carry your phone, your charging, your identity, so that the vehicle can identify you as the user, can allow you to disconnect them. Of course, under emergency, then the management still have buttons to disconnect them. I can see many scenarios. Sometimes the communication Wi-Fi or the Bluetooth is not working very well, then the user cannot unplug their charger. So somehow this kind of communication do have some delay or uncertainty. So all this kind of charging facility, we do need to have ground connection. Although the ground is not connected to the battery, but however, ground connection is to protect to all the communication sensor and also the vehicle control unit. So you can see that basically we can quickly calculate what kind of current requirement to do the charging. I think this kind of tutorial quite straightforward. To assume that if the vehicle this kind of the energy storage, kWh, and then for fast charger, we use certain C rate. That can be 1C, 2C, or 0.5, depend. And then if a charging station, we got N number of vehicles. What kind of power will be needed? What kind of current will be needed? Then basic equation, you can see that. Then the total power will be number of vehicle power, and in average, times number of vehicle times the C rate. So this C rate will be divided by the equation of power. The equation of power will be root-free voltage and the current and the efficiency and power factor. Then we quickly can calculate the amount of the current needed. So that's a simple way you can calculate your site. And what kind of current will be required. For instance, you can go home to calculate if you got 10 vehicles, each vehicle has 50 kilowatt hour. We use 2C charging. If the voltage is 380 volt, power factor 0.89 will be really common. Efficiency 95. You can calculate how much current will be there. Then we can see the current will be 1,600. So you can see that the current to handle a station to handle 10 vehicles is quite demanding, 1,000 something. And the power requirement will be 1 megawatt. So that is to say, you see a household power, usually about 30 kilowatt one household. So that means if you want to build a charging station with 10 vehicles, in theory, we need to ask PG&E for 1 megawatt. Probably that will be a main problem. You may need to wait for a few years for them to develop power distribution. Probably ask them to do it now is quite impossible. And also to ask them to lay a cable for you from the substation to your place, to your car park lot. You may say a few kilometers. Each kilometer, they may charge you for maybe 200,000. So really expensive. That means the charger itself is not expensive. The land is not expensive. Most expensive is the distribution. So that's the issue. That's why you can see that this simple example, we can see that we have difficulty to install many of the charging stations. So that's why to using level 3 charging, 2C will be level 3 charging will be difficult. There are many car park slots, they don't use 2C, they probably only using level 2. Level 2 more look like 0.2 to 0.3, 0.3 C. So you can see that if you divide this by 6, then the power rating will be something like 150, still really much reasonable. 150 kilowatt equal to about a few households. So that will be possible. So that's why this simple example is not tell you how to calculate the power, but let you know about the requirement of the power if you want to install a charging station. That also gives you a thinking about, in the future, the infrastructure for the whole city. How are you going to develop the power? How are you going to balance the power? So that means, that's why, because of this one, we come to the issue, research topic for vehicle to grid. Because our vehicle will connect to the grid anyway. Then V2G are mainly referred to, we draw the power from the power grid. Sometimes if we are able to provide bidirectional power flow, the vehicle battery can be part of the energy storage, can be backup power. So in this case, we allow bidirectional power flow. So all the company, including EV company and power company, are thinking about that. They seriously develop this concept about V2G because if, like California, we highly depend on the solar power during the day. Then if we're able to provide the V2G, then in this case, during the day, we charge all the vehicle. At night, then we have give some incentive to the car user, allow the vehicle to support the power grid. So in this case, we are able to have a really consistent power distribution. And we can also highly depend on solar power. Rather at night, we need to use a thermal generator. That's not nice to have. So that's the concept. So we tend to, the power distribution, would make use of vehicle as power energy storage. So you can see that basically that's one example for the power requirement, right? So you can see that usually during the midday, we have a lot of the power usage because during the midday, probably then we need to turn on our AC, we need to do some cooking or office thing. When you go back to home, we need to start the cooking. Usually during the midday or up to the evening, we consume a lot of power. Then after sunset around 6, then this portion may not able to provide power from the solar. So what we need to do, we can therefore use energy storage from the vehicle to cover any portion that cannot be supported by solar power or cannot be supported because of the high power in the daytime loading. So that's the concept. Of course, in California, we're much better. During the day, we can have solar power. However, in some other city, probably in more northern part, we don't have sufficient solar power. Then using the battery as the energy storage to provide power during the day or maybe during the night will be really important. So that's my concept of V2G mainly is to try to use the battery energy storage in the vehicle to support the grid function. So that means you can see that today one vehicle have at least 50 kilowatt hour. A large vehicle maybe 100 kilowatt hour. That's a really good energy storage. Battery is expensive, but once we can make use of the battery inside the vehicle, we can save a lot of the investment. So V2G is that kind of technology. We try to connect them to the power grid. And then we also have vehicle to everything, V2X. So the vehicle don't need to only connect to power grid, can connect to any other thing. That including vehicle to building, we connect our battery to a building. We can connect our battery to other vehicle. So that means you can see that this picture and all the things for the whole city planning, we can able to connect it. Now the renewable energy, the solar power, wind power, we can therefore support to the grid, and the grid can able to use it to charge up your vehicle. And then the grid here, the charger must be bidirectional. We're able to allow power from the battery can go either way. And then once we do that, we can able to even up the power load by using a battery. At the moment, we got many power sources, including solar power, wind power, and maybe thermal generator. But how to turn them on, because we don't need to optimize the power, even though as I mentioned a few times, usually the low-cost generation will be used first. When the demand going too high, we need to turn on more generator, then this generator will be more expensive. So the power company try to save their investments, try to save their costs, operation costs. In this case, they don't like to turn on all the generator. So only those generators only for backup. So if we're able to make use of the battery inside vehicle, that can be balanced up all the power generation. So we can able to use battery to even up all this peak demand, and then we can use throw energy storage here to cover up. So this, of course, we call it the peak shaving. So that's a really common term we use in vehicle design or the modernization of power grid. So here we just concept to you about we have vehicle to grid. We also vehicle to everything. So using the vehicle can cover up a lot of the energy storage requirement. We mainly make use of battery inside vehicle to do the job. So that means the feature to do that, then of course the charger must be bidirectional. So we can charge the battery, can discharge it back to the power grid. So today our power grid do accept power. So usually our normal vintage version here in a building, we usually inject maybe 30 kilowatt. They won't notice anything because 30 kilowatt is very, very small. When you turn on a few light, that will be consume the power. So even though in the lab, when we do experiment, we can also feed our power back to the grid in order we don't need to dump the system. Like one of the experiment I'm setting, I'm doing the, say the motor genset experiment. So when we power up the motor, become a generator, this power will feed back into the power grid. In this case, so that's a much better choice. If you want to the generation, dump them into resistor, that's wasting energy. So that's why the generator experiment, we usually try to push the energy back to the power grid to feed back into our building distribution system. So in this case, we do need the grid support. So our grid should be able to support when we release the stored energy to the power grid. So they have that kind of facility. In some countries, some cities, they do the approval. If you want to feed your power back to a power grid, then you need application. Why is that? Because many people put in the PV, they all feed their current back to the power grid. Then during the day, that will be too much. Then will make the voltage not stable. During the day, everybody doing the same, then the voltage may rise, which we don't want that. All the power company, they got a code. That means the voltage can only plus or minus 5%. So that means if voltage here of 120, 5% roughly about just a few about plus or minus. So that means 125 down to 115. You can't have too much flexibility. Otherwise, the government will sue them because you don't comply with the regulation. So that means everybody feed in the power, the voltage will rise. That is not good. So that means to do this, we need to have peak shaving. So because during the day, we have too high power, then the power will support to the AC system. During the day, especially California, everybody turn on the AC, then the power utilization is too high. Then in this case, if you don't have sufficient power, and people sometimes they charging vehicle during the day, they will charge the vehicle, so the power demand will be really high. So in this case, then we need to have a peak shaving. So that it will say, whenever you see the power is too high, then the battery vehicle can use the battery to feed back the energy back to the power grid to support the power. Especially during the day when everybody turn on the AC, even though turn on the solar, we don't have sufficient ventilation. So we need to make use of battery. So the one way to so-called the load sharing to shape the peak will be using that feature. Another thing will be grid balancing. So V2G, this technology mainly contribute to the main duty is to balance the power grid, make it more stable. So mainly to balance the supply and demand. So when they see a supply demand not equal, then the power deficits can be supported by a battery. So that's the main idea. So if you don't do that, then there will be power outage, So that means the battery doing a good job in case the supply and demand is not balanced. They need to do that. In the past, then the PG&E, a power company, they need to use a lot of the switching gear to do that. Once they see not balanced, they will turn on and turn off some power generator. So that will be really complicated. There are consume a lot of the energy, a lot of the dump many waste energy. But however, battery move much better because battery response time for battery will be really fast. Probably within seconds, we can support the power. In this case, if we see any power imbalance, we can quickly can use the battery to support the power grid. You can see that if you use conventional method like turn on a power plant, increase the power level for power plant, it may take quite a few minutes to do that. So that's why I can see that today we still see a lot of power interrupt, power shutdown. Quite a few years in California, quite a few years in Washington State will be quite often. Usually it happens when there will be heavy snow or maybe some power fault. Then some generator shut down, some distribution shut down. Usually any distribution, they will allow at least more than one source of supply. But however, if one source supply is broken, we only allow for one of them, and the voltage may not be stable. Sometimes, if not sufficient to do that, the power will be interrupted. Maybe interrupt for a few minutes and then to rechannel the power. Sometimes the control system, they will try to find which source can able to support this district. So we connect all the wiring. Of course, all doing electronically. But however, you can see that once we got the battery system, then our battery system is distributed along the whole country. So which location we need more power, we just talk to, using V2G method, talk to the vehicle, they connect their battery back to the power grid to support the power deficits. So that's one of the methods. So again, using the economic benefit will be firstly, any power shutdown will be really expensive. They will lose a lot of money. You can see that if a computer, they are using electrical power, suddenly power shutdown, they may lose their data. A printing company, if they're printing, power shutdown, their printing will be interrupted. All that lot of the printing will be damaged. Like the textile, they doing the sewing, they manufacturing the textile. Then any power interrupt, the whole batch of the textile will be destroyed. So that means many of the industry, they don't allow to have any power interrupt because it's too expensive to do that. So the main economic benefit for V2G, you can use the backup power from the battery, can support the power grid. In case anything happens, the battery response time will be much, much quicker. In theory, less than half a second, less than 10 milliseconds, able to support the power. And then this method, we can also allow more renewable energy integration. Before we can see that we find renewable energy is really highly unstable. Even though in here we're using PV, yesterday the sunlight is so strong, but today we have no PV power. So you can see that if our city depend on PV only, then yesterday we got surplus, but today we have no power. So how our city can survive? So in this case, the city, they need to install many gas turbines in case like today they turn on the gas turbine. That's not good implementation. But however, if we use the V2G, then today we can ask the vehicle to support the power grid for only 2 days. That would be nice to see that. So V2G is able to help us to fully utilize the renewable energy because we do have a really strong backup. You can see that each household may at least have one vehicle. One vehicle have 50 kilowatt hour. That can be able to support you for the whole evening. Yeah. So, and then if you're including other buses, maybe public transport, you have a lot of the energy storage. So later on, I'll show you some more data about how that energy storage look like. And then fleet application. So V2G is particularly relevant for fleet operation and multiple electric vehicle. Fleet vehicle can be connected and contribute to significant energy to the grid when not in use. You see all the commercial vehicle don't need to turn on all the time. especially for commercial vehicle. Then at night, then usually they will dock the vehicle, park the vehicle, so the energy can be used, especially for large enterprise. They should have many vehicles, so that all that vehicle can provide really significant energy storage. So because for public user, if you want to make use of the energy storage for the vehicle, not quite stable, because sometimes you may use your vehicle at night for entertainment for other purpose. So you cannot control the timing when you can connect your vehicle to the grid. But however, for enterprise, for public utility, for public company, they feed their vehicle, like for example, like our postal service, they got many vehicles. Then at night, they don't deliver the postage. Then all the vehicle can be used for energy storage because they below their regular timing for their service. We know how we can make use of their battery. So that's why using this method, we can develop a smart charging management to manage which vehicle, which location, what kind of the battery or energy storage will be made available. We're able to design really smart power distribution. So this kind of technology is not difficult. It's a kind of calculation. I think for the last 10 years, there's many millions of research papers talking about this V2G, how to make use of the battery charging to support the whole infrastructure. So, but however, to do this, we need some protocol, standardized protocol, how to do that. Because for many different users, they have their own choice of connection. So that means for the V2G technology, we do need to develop protocol so that we don't need to talk to each body. Everybody can stick to this protocol. Then we can able to connect our vehicle to a power grid in order to support the whole infrastructure. In this case, the good thing, once we do calculation, do that management, then we are able to prolong the battery lifetime. We can able to regulate the whole infrastructure, have a much more stable power supply to the whole system. Certainly, that can have high environmental issue as well. The whole environment can able to make use of this kind of sustainable energy, make use of battery. The battery is there anyway, and the battery lifetime is now getting much, much better. I think maybe 10 years ago, you don't quite like to do that. But today, when you have many, many vehicles, all the vehicles have really good lifetime, probably you contribute your battery to the power grid, it's quite okay. You got a BMS to control your current, you won't damage your battery anyway. But you be there, stand by in case the power grid we need your service. You provide to them, you can earn some incentive. So that's why this concept highly supporting for the renewable energy. You can make much better use of renewable energy. You can reduce all the fossil fuel, the thermal generation. Then we talk about so many good benefits for V2G. Then would there be any other disadvantages? Any difficulty when we implement the V2G? Besides looking at this one, so we just talk about that. What do you think about V2G? What kind of difficulty you may think of? Battery lifetime.
Because the users would not want their battery life to degrade too fast, right? Because everybody thinks that the battery life is gonna be like for like 7-8 years of what the manufacturers promised, right?
Yeah.
But if they use a V2G, that might reduce to like 4-5 years, I believe, if it's getting used very often.
That's really true. The manufacturer only guarantee you how many cycles,
Yeah.
with how many mileage. But if you use your battery for support the power grid, the manufacturer will not guarantee your battery. They may say you overuse the battery. They don't provide you the service. Battery is most expensive, more than half of your vehicle. If your battery is being degraded, then nobody like your vehicle. You see today, vehicle, once you bought your vehicle, then if your second hand would be much less than half. Say if you get a Tesla Model Y, say 50,000, then once if you use it for 1 month, if you sell it back to anyone, the price only about say half, 30,000, maybe 25,000. Because they know that when you second-hand battery, second-hand vehicle, especially electric, doesn't worth any. It's mainly about the battery. They don't believe your battery is still good. So that's why the battery is one of the issue for V2G.
But could this be changed with the solid state batteries? Because they have a higher life cycle, right?
Yes,
They have more life cycles, like almost double
of course.
than the lithium ion.
Yes, what we are looking for would be next stage of development must be solid state battery. That's why we also ask you some homework question about solid state battery. It's good. Solid state battery have much longer lifetime, higher safety factor. Conventionally, all the lithium-ion battery, the electrolyte is liquid. So that means in case of accident, collision, punch through, then your battery will really get very easy to get explosion on fire. But solid state, they're solid. The separator are much better under the solid state development, much safer. That's why you can see that if you drive an EV, we do a number of cases. If you drive an EV, you think it's quite okay, but if you go for a ramp or go for some big stone on the ground, you run through them, the stone will hit or have impact to your battery. All the battery under in the chassis, under the vehicle. Then if anything hitting your battery at the back, underneath, the battery just look like an impact to the battery. Then the battery inside could have damage to the separator. Then many cases, if your then battery explosion, battery fire will be, that could happen because the battery are that's kind of square when you put them on or lay them on the chassis. But if you have a stone or big thing to hit underneath, that could, this force can therefore damage the battery, especially the separator. So if your vehicle pass through any ramp accidentally, which can damage your vehicle, you need to be really careful. So anyway, again, we can see that V2G is really good technology. We all talk about that, but there's still a lot of the difficulty, that including the infrastructure charge. The thing is, we do need many of charging stations. And also, for especially they should be on grid connection. But today, we don't have that many charging stations yet. As I mentioned before, to develop charging station, we need good support from the city, from the power company, say PG&E or other power company. So in this case, this has been really slow, mainly because we don't have sufficient electrical power source. We don't have sufficient power supply anyway. So that slowed down all the development. You see, there's a chicken and egg problem. The power distribution, PG&E or other distribution company, they don't have sufficient power. They cannot allow you to develop your charging station. But however, if you use V2G, our charging station support the power to the power grid. But since they don't have sufficient power, they don't allow you to do that. The consequence is they don't get the benefit from V2G. So that's why either one of them should need to move forward to the next step. And also about all the regulation. At the moment, there's no well-developed regulation to tell you what to do with V2G. You see 99% of the vehicle company, their battery charging only unidirectional. You can only charge the battery. You cannot discharge your battery back to the power grid. We don't have the facility yet. Maybe they already implement, but they don't have that kind of the feature to allow you to do the connection. So then 99% are not doing that. So next time if you want to think about V2G, still need a new version, maybe quite a few more years, V2G. So that means the government should push the vehicle company to allow V2G implement in their vehicle. So also another thing about economic issue. About the financial benefit. You see, we like to see that, especially the power company, but however, what kind of incentive you provide to the vehicle user. When you feed back your power to the grid, the thing is this grid power is not only the electricity you pay for them. For instance, in California, it can be 40 cents per kilowatt hour. But if you use V2G, you pay the feedback in the power grid. If they only give you 40 cents, you don't like to see that because you're damaging your battery. They need to give you higher incentive. But the thing is, if you get high incentive, then PG&E may think better to produce a few more gas generator. So in this case, it doesn't sound good because the cost benefit, economic benefit doesn't make any sense when you use V2G. We like to do that, but the car user may ask for higher incentive to connect your battery to the power grid. So there's something we're not quite sure about that. And also technology limitation. So at the moment, the existing battery in the vehicle, they try to reduce all their costs for the vehicle development. You can see that if you buy a vehicle, for example, like Tesla, you need to pay for 50,000. But the ex-factory, 50,000 with all the tax and also all the other auxiliary charge. So the manufacturer can only receive 35,000. You see 35,000 for a whole vehicle, they need to pay for the design, they pay for the patent, manpower, manufacturing, the battery and component. So actually the profit margin is really, really low. Only talking about 10%, maybe even to less than that. So that means they don't have any kind of the momentum to change the vehicle to the bidirectional power flow because they need to add an additional component there to control the V2G, control the change in the bidirectional power charging system. So all these things will be a kind of the issue, how to reduce the costs. Another thing would be the battery itself. V2G means that your battery will be shared with many other users in the power grid. As you mentioned just now, the nighttime is one of the main issues. We don't want to overuse our battery. If our vehicle, we may charge your vehicle maybe twice a week. So in theory, we can use your vehicle for 7 years without any difficulty. But once you have to use your vehicle battery once a day, maybe a few times a day due to V2G, probably your battery lifetime can reduce to maybe 3 to 4 years. You don't like that. You're not quite sure how often your battery being used. What is the depth of the charge you go down to? Something you're not quite sure. So that causes a lot of the hurdle. So that means that's still the main difficulty for V2G anyway. Another topic we like to say would be about the load management. Just now we mentioned about the power requirement for the whole charging station will be really high. So in this case, we need to manage how the current being utilized properly. When vehicle, of course, once we establish our charging station, we like to have a lot of parking lot, have the charging facility, then usually total power requirement will be higher than the power distribution. Just like in a house, your power input to the house, the cable can only about 30 kW. But if you add all your appliance in your house, certainly more than 30 kW. If you turn on a hairdryer, will be say 2 kW. If 5 people in your house all turn on a hairdryer, already 10 kW. Plus the refrigerator, probably will be maybe 1 kW. When you do the cooking, maybe 5 kW. Turn on the AC, another 2 kW. That's why when you turn on everything, certainly more than 30 kW. But however, that's so-called load management. Just the power company, they have some statistics. They think nobody will turn on everything simultaneously. So the actual power supply to the whole district would much less, maybe only 30% of the peak power. So here you come to the load management. So just now our calculation for 10 vehicles require 1 megawatt. Then when you talk to PG&E, probably they won't give you 1 megawatt. They only give you 300 kilowatt. So you need to think about how you're going to manage. So if 300 kilowatt, you can only allow 3 vehicles to charge, or maybe 6 vehicles have a 1C charging, or maybe 12 vehicles have slow charging, medium power charging. Maybe those vehicles pay more, you can allow 1 vehicle have fast charging. So that's how we're going to manage them. So that means load management will be how we're going to manage your own car park, how to delete control the current to each of the charging lock, that including what kind of input power being limited from your distribution, what power can allow from PG&E. Number of vehicle. The number of vehicle in your parking lot, you don't know, can be vary anytime. And the parking duration, how long you allow for each charging. If, say, for many level 3 charging, they only allow you 30 minutes. You need to go because it's very expensive, the supercharger. So that means the charging power must be vary with time. If you can see that if you go to supercharger in Tesla, although they talk about 250 kilowatt, but if 2 vehicles go there, they will share the power become 125. So that means you can't fully charge a vehicle within 30 minutes. So if more vehicle, then the power will getting less. So that's how they manage, because they believe there won't be any scenario all the vehicle will press the button together. Yeah. And some vehicle initial current will be higher. When you near the end, then you can change to CV mode, then that will save some current. So that means the load management, of course, will depend on many things, depend how much you're going to pay, how much is SOC of your vehicle. Do you think low SOC with high priority? So all this kind of control parameter actually decided by your load management program. You can make a decision to set the priority, then to manage your own car park load. So that means we need to consider about the vehicle connection, the power output for the charging, and also what kind of full power will be available. So that means we need to develop a smart charging system with a really good monitoring mechanism. When the power distribution come to here, then all the vehicle able to connect to the charger like in such a way. Then we do have a power cable for the power, another with communication control cable, which is able to understand the condition for the vehicle. So that means the BMS like the control pin for your charger, usually all the charging connection have at least 2 control pin. Then you can use it to understand the vehicle condition. You can understand the vehicle like the SOC. Then you can use SOC to determine about how you're going to charge the vehicle. You can match up which vehicle to charge first. You see, when the vehicle has 20% SOC, then up to charging up to 80%, within that 30 minutes, probably can sometimes you don't need to give them full power. You can wait for those vehicles have a much different kind of the setting. Maybe they like to pay more, or they have been queuing for a long time. You can manage them. Then, so that means you need a really smart control system determine your algorithm, how to determine which vehicle to receive how much power. So that's the thing we need to look into. So that program, many researchers have been thinking about this program. This kind of program is not highly technical. It's mainly about how to balance the power. That depends on a few control parameters. So another section will be talking about the battery swapping. Last week, we also talked about the battery swapping, which is a really important area of the whole infrastructure. The people think about that because they know that that's impossible to supply electrical power for all the vehicle when they all press the button to charge the vehicle, especially at night at 6, at 5. When you return your car to your own garage, everybody turn a button to charge. In this case, you also need to turn on your AC, do the cooking, shower, everything. The power will shoot up. So that means the charging may not be quite visible. We like to make sure the vehicle can finish charging within a few minutes, like gasoline. So that means battery swapping has been discussed for the last 20 years, 30 years. Once we have electric vehicle, everybody will think about this concept. So today we're going to analyze about this concept, why it's successful, why it's not successful. So the key advantage, of course, you know that you can shorten the charging time, usually about 3 minutes. Should be quite standard time you can swap your battery. That will be really similar, maybe shorter than you fill up your car with gasoline. Then no user will be have worry about your mileage, because if you do have many battery swapping station like gas station, we no point for to worry. Today when we drive our gas vehicle, we never worry about the range, because we can get a gas station probably within 10 minutes or 5 minutes and everywhere. But for charging station, it's not the case. So that's why we worry about driving an EV, but not a gas vehicle. So if able to implement the battery swapping in many locations, then within 3 minutes, we can able to finish the battery swapping. Then once we do the battery swapping, we're able to prolong the battery lifetime, because very often we may use supercharge. In this case, that's not good for the battery. But when we use the battery swapping, the battery will charge by the station. The station will not use supercharge. They only use medium charge. That will be good for the battery. You can prolong the battery lifetime. And also for the load management as well, when we have many battery inside the charging station, the charging station can use the battery to contribute to the V2G to support the power grid, so the whole power network can become more stable. They can determine which location, how much power to be used to charge the battery, because they can do it more systematically, because they are bigger enterprise. But if it depends on the individual user, user A may charge at that time, user B may charge at the other time. We have no control to the user when and where to charge the battery. That makes the calculation, make the balancing with the V2G really complicated. But if the whole system are controlled by a few limited amount of the battery swapping company, they can manage a charging plan, how to make use of the charging, how to make use of V2G, then it's much easier to manage. So that means we can able to prolong better load management, much better. Another thing about recycling and disposal, because they are organized company, how they dispose the battery, recycle them must be in their company article. So we don't need to worry too much about it. But however, for individual user, it's really difficult to predict. When you have vehicle, say 7 years, you need to dump into landfill. Probably the way you try to recycle the battery, try to dispose the battery is unpredictable. So that will damage the environment. But for big company, they don't do that. So that is key advantage for the battery swapping. But the difficulty for this will be, first thing must be standardization. All the vehicles, there's so many, more than 50 brands of the EV. All of them have different design, different package. How are you going to make up the battery standard, the battery package? The voltage, current, size, form factor are all different. And also you need to think about how to create a mechanism to swap the battery. You need to have some kind of some kind of holder to do that. But today for all the EV, because they try to make it very high density, so their chassis design is not allowed to have battery swapping, because they want to reduce the room, reduce the mechanics. So that means once you use battery swapping, they need to redesign their chassis, put more mechanics there. That is not convenient. And also reliability of the battery pack. As you say, when you swap with a battery, you're not quite sure the lifetime, how good the battery is. You have some kind of the worry about what battery I have this time. So that's something we are not quite sure. So sometimes you may swap your battery, a new battery. You may swap your battery only about 1 year, maybe 5 years, maybe 7 years. So that's why it's something you don't quite like to see that. And all these things, we need a really good business model, how to make the model properly. Because as I mentioned last week, there's many companies are not really successful. So their business model is not good. So we need to develop a good business model to handle that. Like in here, Better Place is Israel company. It's a really big company at that time, 2008. But however, it filed bankruptcy in 2013. So I think probably their business model is not good. But however, there's many successful cases in here. Like in Taiwan is a Gogoro scooter, and in India, Movish battery swapping there. But you can see the first two are mainly for smaller vehicle, 2-wheel and 3-wheel. Then India, they do have a bus working on the battery swapping. So that means the successful case more look like small vehicle because the battery is smaller, easier to swap. Or they are the big enterprise like the public transport. They follow government guideline. They need to do the battery swapping. Like the bus, because they do need to charge the vehicle quite a few times a day. The only solution is to use battery swapping so that they can able to continue the service without waiting for half an hour or 1 hour. So here will be some example, some picture I showed you last week as well. That's a better place. The vehicle drive in, then you can swap the battery at the back here, do that. And the Google is the one, this tool is the battery. You can unplug and plug to swap your own battery inside your scooter. Then we also have many other big enterprise working on battery swapping, like NIO, which is one of the Chinese EV manufacturer. And they also doing a job on the battery swapping. So you can click this link, you can see what they're doing. So what they declare will be 3 minutes, they can finish the battery swapping. So that will be more look like standard time for battery swapping. So what they declare will be all the battery, they will check, make sure the battery will be good condition before they or during they do the swapping. So that will ensure that the user will be feel comfortable to that. You can see some picture, the vehicle go inside here. Then this picture show how they swap the battery at the back. And then once do that, they can try. So the thing is this battery swapping highly depend on their own vehicle. They cannot swap the battery with other brand. So this company, NIO, they manufacture about many their own brand and model. So they mean only their own brand, their model, their own battery can be swapped. So that depends on how big their company is. If they're a big company, they're able to provide the battery swapping, then they also need to manufacture their own vehicle. So that means small company probably may not be successful because they don't have sufficient power to develop many swapping stations. That will be expensive. They need to have very number of the cells to support the battery swapping. So for instance, so that means small company probably have difficulty to do that. If say Tesla, they have large company BYD. If they change their manufacturing method to battery swapping, probably many people follow it. So that's one of the things we're not quite sure. But this company has been founded in 2014, more than 10-year development in battery swapping. So that means this kind of the concept has been there for many years. Many companies chasing for this concept to develop their EV. So this is the one I told you just now of the Taiwanese company, Google. So the battery swapping, like in this picture here, the scooter, moped, and motorcycle. So this picture will show you how to do that. They just have two of this. So unplug and swap them with the charging station. Simple and easy, just like in here. So this kind of the swapping station, because they're small, you also operate by you because they're only for scooter. So that means they don't need a really big station to do that. Just like Better Place, you do need a big location, like to 6 car park station to do that. But this thing is just more look like they just putting any heavyware. You can just swap their battery. So you see in Taiwan, there's how many stations? More than 12,000 stations everywhere on the Taiwan island. So the scooter, it will just take them about just 1 to 2 minutes to swap their battery. So that's why this will become really successful. They also start their new operation in India. So they not only locate in Taiwan now, they also launch their operation in other countries. So you can click this link, you can see what they're doing. Another company will be in US company. They're also working on the battery swapping called the Ample. They found it in 2012, also more than 10 years now. they also develop this kind of the charging station like this, drive in, then swap the battery at the back. And then they also have an app to show you the location for their battery swapping. So it's in San Francisco, not really far away from here. So that's how they think about they want to develop many of these charging swapping. The car drive in, you can swap the battery and then go away. So the care then only take them 5 minutes to finish the swapping. But I checked their website, I didn't see that many development. Probably that would more look like a proposal, more operation under development. I did not see any massive product development. As I said, all the battery swapping only can swappable with their own vehicle. No other vehicle allow them to swap. So that means they need to develop their own vehicle, develop their swapping station. So if the company is not big enough, then that operation will be difficult. You see, today when you buy an EV, then probably you may go for some large brand, maybe Tesla, maybe I don't know, maybe some large vehicle, or maybe BYD model. So in this case, you will go for this vehicle, you're not quite sure their performance. Today, when we buy an EV, we are not really looking for the battery swapping, probably looking for the price of the vehicle, and also the lifetime for the vehicle, and also the incentive for the vehicle, if they're good looking or not. If a vehicle is not good looking, then it's also really have difficulty, you're going to buy that. So this vehicle is like that. I don't think it's really good looking. So that's one of the issues. We still haven't seen two major development for this vehicle. So battery swapping highly related to their own model. So that's one of the issues. Another company called Altron, it also developed in year 2000. They still are one of the major players for the battery swapping in mainland China. So they already developed 30 different kinds of model for EV battery swapping, for 30 of them. So quite a big number. And then they also have 16 predominant OEM, including all these brands. They're actually working with them to develop their own vehicle to become swappable. So they have 800 of battery swapping. So that means when they work with this company, their battery can be swappable using their technology. So that's a nice thing to have. What they're trying to do is they try to unify all the battery swapping protocol. So if you go for this company vehicle, they are all quite a good brand in mainland China, then their vehicle battery can be swappable. Then if you're using this vehicle, you go to their swapping battery station, then you can swap the battery within 3 minutes. So that's how they're going to operate, to make sure the vehicle battery can be swappable. But how successful it is, we're not quite sure. It's still under developing. Last few years, they've been doing a lot of work. Last 3-4 years, they have been extending their development. So we need to wait for a few more years to see how the customer accept this concept. So BIAC is also one of the really large company in China. This company not only producing conventional EV, but also producing this kind of the battery swapping. So their technology come from Altron, as I mentioned just now. They start to look into this technology in 2016, and they launched their first version 2018. I think this technology also come from Altron as well. So now then, their own brand already have 200 of battery swapping stations in China. So today they also launched, they're going to work with CATL. Do you know what CATL is? Anybody know about it? CATL is the biggest battery manufacturer in the world. Also one of the major battery supply in mainland China. So most of battery are supplied by this company. So they're now working with this company to develop the battery swapping. They just announced it in last year. So I think something big is happening. So what you can see from all this example will be, this is battery swapping could be another technology we are looking into. Many companies in here, you can see that in here, in mainland China are using this technology. Even though in US, we are also looking in this technology. But the thing is, in US, we don't have that many EV manufacturers. We only have Tesla. or maybe GE or quite a few, they not yet look into the battery swapping yet. They're only looking in how to reduce their cost. But once you use battery swapping, you increase their cost of manufacturing. You also need to develop the charging station. If you only develop an EV, you don't care because there are many charging stations out there. So that means you need to invest more in the battery swapping. But so that means US will be doing this. Taiwan is doing this only for small vehicle. And then China is doing this for a number of vehicles. Like they just have a partnership or enterprise all work together, have this kind of the battery swapping technology. They already have 800 stations for all this series and working with 16 OEM, 16 here. I only list a few of them, but 16 OEM using this technology. So could be something happening in the next few years. We wait for a few more years to see if that will be successful. So the thing is, charging always a big issue. We're talking about using, say, solid state. Next, we're talking about using hydrogen, because mainly about energy storage. We need to go for hydrogen. But now then, if we go for battery swapping, probably we don't need hydrogen. If we have a really good facility for battery swapping, 3 minutes, good enough, much faster than you go for, yeah. So, and then your vehicle don't need to own the battery. In theory, your Tesla, 50,000, probably 25,000 go to the battery. Then if you don't own the battery, your Tesla only become 25,000. Nice to see, to hear that. So that's the issue. Battery swapping will come into such. And then battery swapping can also support the power grid to make the infrastructure much more beautiful, much easier to manage. So that's why that could be a lot of the thing issue. So next thing, so what do you think, what next for the battery swapping?
Will take time.
Take time, yeah. If I ask you, how are you going to do a research topic to support the battery swapping? What can you do? If you ask you, your PhD will go for battery swapping. What technology are you going to research?
On battery swapping,
We want station to do it as fast as it could and somehow to arrange the batteries in an order, like new batteries on site and medium used, most used, like all in an automated process, right? So figure out what's the life of the battery that we are swapping right now and have a similar kind of battery.
Yeah.
To swap with it.
make a protocol which is compatible for
Yeah.
many brands.
Good. We need to develop a very good protocol so that everyone follow that protocol. For some large vehicle, we may need 2 sets of batteries, small vehicle 1 set. So that means for some large vehicle, they swap 3 sets, probably lorries, 3 sets, minibus 2 sets, bus 3 sets, private car only 1 set, mini car only half set. The thing is, once you battery swapping, you don't need to swap the whole battery. You can only separate to a section. Sometimes your vehicle, you don't need to go for 500 kilometers. Maybe a city driving, you only need 100 kilometers. Then your battery swapping can be swapped with a much smaller battery. You can also select different age of battery. If you pay more, then I select today with a new battery. Just like when you go to rent a car, then you can select different kind of vehicle you're going to rent. If you rent a car for 2 years old, probably the rental price will be lower. If you rent a brand new vehicle, your rental will be higher, right? There's many kind of the game, many kind of the management method you can come with. Right?
But if someone gives out an old battery and gets a new battery, right? He wouldn't have to pay that much price for it, right?
Yeah.
So it would be a much lesser price.
Yeah.
And what if he just decides to never go back to the battery swapping and keep that battery? So that's like a loss to the battery swapping station, right?
Then you do have a protocol. because you need to think about how to solve the problem, including your rental, more like rental of your battery. You rent a battery together with fully charged rental. So next time, when you want to swap the battery, you need to pay for the time of your rental probably. Then they will also check about how much you use for the battery to calculate how much you're going to pay anyway. And then you also depend on vehicle can have the charging facility. But probably if I design this kind of vehicle, we should able to have charging facility plus the battery swapping, both of them should be there. But what you say is quite correct. If I swap with a new battery, you need to pay for more anyway. Then may last for 1 month, 2 months, this kind, and then you need to return, you need to continue to pay probably. I don't know. So that's a protocol you need to think about how to manage. So that's a lot of the thing you need to look into. You can write quite a few research paper on this topic. Yeah. Something going on here. You can see this development means something is happening. Any other question? Okay. So like BAIC is one of the major EV company in mainland China. So that's how their factory look like. So they have this factory plan, how they organize them. You can click the link, you can see what they're doing. So that's how they deliver the vehicle to each portion for the assembly. And then like in here, this will deliver to each corner to assemble the vehicle. So that's why I can see that how the EV manufacturer now is all highly 100% automatic. And before, when I make my first vehicle, I think I told you, I'm the father of electric vehicle in Hong Kong. When we make our own vehicle, during that time, we still semi machine manufacturing. We make the vehicle all using machine, but final touch-up, we still need to use our engineer to fix that. So that now today changed so much. We're all using 100% robot to do all the manufacturing. Anyway, so next important area of development must be the dynamic charging. So dynamic charging means when the vehicle is moving, then we charge the vehicle simultaneously. Obviously, you can see that will be important because like the user, we don't want to wait 30 minutes, half an hour to charge vehicle, especially for public transport or commercial vehicle. You see, if you're not using battery swapping, the only thing we can do is conductive charging. With conductive charging, you take about 1 hour or 30 minutes. If you have rapid charging 30 minutes, as we told you before, it may damage the battery lifetime. It's better to charge the battery slowly using 0.2 C or 0.5 C to charge your battery. But every day, especially for public vehicle, commercial vehicle, you need to charge twice a day. Each time you use fast charging, your lifetime will be getting lower. So that's why if you think about dynamic charging, you can charge the vehicle relatively slowly when you're driving a vehicle. So that means you can see that if you got highway here, then we implement many coils at the bottom. So when the vehicle driving on the highway, for example, like the link number 1, we put a many coils there. When vehicle drive along, they can just charge up. Yeah. For instance, if you want to go to Lofton Park, then in the I-5, we're putting many of the coil over there, then you don't need to worry about the charging. Once you drive in this location, your vehicle being charged. And then we can also put in some sensor. You can using sensor to pay how much you go for. And so that's quite nice to see that. We can also put this charging maybe in the traffic light or maybe bus stop, many locations, you can do that. So dynamic charging allows you to charge everywhere, especially when the vehicle is moving, you can also charge it. So we are able to charge continuously. We don't need to find any parking lot. The thing is, find parking lot to charge is also very expensive. When you build a charger, you also need to build the parking. So that's why that will double investment. But however, if you put a coil in the highway, in any road, then you don't need to find a parking space. You can save of your investment for your parking station. So this kind of thing must be using wireless. Although you can see some vehicle, they got the catenary at the high end, then they use overhead line catenary to charge the vehicle at top. But in here, this technology mainly go for using the inductive charging. So that means we charge the vehicle when we move along this highway using wireless power transfer. The thing is, today, the wireless power transfer power is not that high yet. So usually about, say, 1 meter square, that size, probably the power transfer is not that high. I think usually up to about 20 kilowatt, maximum will be about 40 kilowatt. And some research team can go higher. So that means you can't have fast charging anyway. So they are more look like medium charging. But when the vehicle is under the cruising, that power should be sufficient to power up the vehicle. Then for buses, then we usually put more than one coil, maybe 3 coils along the vehicle. For private car like this, we only put 1 coil. Then we're able to provide something like 10 kilowatt of power transfer. Then that will be quite okay when you do the cruising. So that's how the technology look like. So of course, this concept was really simple, but now then we are thinking how to develop that. So what do you think about this concept, dynamic charging? What kind of hurdle, what kind of difficulty when you want to implement this kind of wireless charging on the road?
I think expensive.
It's expensive, yeah.
Second, the area you are covering, it is dynamic, so vehicle size and all those things need to be covered, so it's quite challenging.
Mm.
The main thing is infrastructure.
The infrastructure is problem. That relate to infrastructure, yeah. I think, of course, you need to develop many coils. Probably every location along the highway, you need to put many coils. Not only single coil, probably coil come with the inverter to drive them. That will be expensive. And also safety, EMI. You may a vehicle drive there, then you produce some electromagnetic field. That will affect your own vehicle, but also affect other vehicles nearby. And then people will scare about, would there be any safety concern if you drop any metal on the road? Then vehicle cover them, then the metal will pass through magnetic field. Would that be cause another issue? And then another important thing would be city development. If you want to implement all the coil in the city, you see if your highway like I-5 or other, they're quite okay because the highway may not have anything underneath. But if our city, there's so many facilities in our city, like the water pipe, gas pipe, electrical pipeline, and also a lot of the internet wiring. So it's impossible you have any additional room to put your coil and inverter under your road because they're fully occupied. They are very busy underneath. And then if you want to remove them, it will be very, very expensive. So one of the things for dynamic charging could be we try to implement many of dynamic charging all along your city. In every highway, major road, traffic light location, you put all these kind of the dynamic charger. But there's no room underneath. To remove all the facility to put in yours will be difficult. You can't just put it on the top because your radio wave, your high frequency rate may affect the gas pipe, may have gas explosion. Your internet cable, your communication cable may be influenced by the high switching frequencies. So that becomes a problem. It's nice to see that if you do it in the new city development, all city development will be getting difficult. So if you're going to develop a new city, a new smart city, then that's the thing you need to do. But for all city, that will getting difficult. So that means dynamic charging have many names. We sometimes can move and charge MAC. So that means we try to charge the vehicle while we are cruising on the vehicle or stopping the traffic light, idling, waiting. That's our concept, how to do that. Then the good thing is saving the charging station. In the past, we worry about we need to build many charging stations to charge the vehicle. then that means that is a big difficulty for city development. But now then, once we use dynamic charging, we don't need to worry about city, this kind of the charging facility. Everywhere will be charging facility. So in a way, if we calculate that maybe some benefit. You see, if we build a charging station, of course, in here, then we can build a charging station on one level. But in some cities like New York, we cannot build any charging station anymore because all congested. If you high-rise charging station, then we need to also input all the charging network, then the electricity supply, everything will be more difficult. So that means if we build any new charging station in a BC city will be really, really difficult because it's really expensive to build a charging station there. But however, if we build them on the highway, on the road, then we can actually implement them underneath the road. We don't need to invest additional costs for the landing. So MAC transmitter usually embedded on the road surface. So this method usually can be conductive, can be inductive. Of course, inductive will be more common. Conductive, that means you need a physical contact, maybe some metal connect to the road surface, maybe overhead line. So the common thing you can see in many cities will be the trolley bus. So you can see many trolley bus in cities. Sometimes they will using the conductive charging method, but that will has some restriction to the road, and also overhead line also have a lot of issues. Some building may not be like that. Architectural design also has some difficulty. And that's why wireless power transfer will be much more useful. But this technology is still not quite developed properly yet. We can do wireless power transfers for stationary, but when the objects moving, then how to transit from one coil to the other coil will be a big problem. And the separation between them usually at least about 15 centimeters. Such a big separation, as I showed you last time, the efficiency was 85%. But once you need to move the coil from one to the other, the efficiency will lower. Between the coil, then there will be a lot of ripple. So that means this kind of thing we still need quite good research to develop them properly. And the cost also really important. So how to develop so many coil will be quite a challenge. So of course, the key advantage for direct charging is quite obviously because you're able to provide the vehicle charging. We don't need to worry about the range, even though long trip will be quite really much feasible. And the infrastructure like the charging station can be eliminated. You don't need to worry too much about where and how to locate the charging facility, because usually for city development, charging facility will be important. Especially under the transition, we still have gasoline charging station, but we also need to build a number of electrical vehicle charging stations. We don't have sufficient building, sufficient land to do that. Especially for well-developed city, for example, like in Tokyo, then you want to develop many charging stations, it's impossible. And because the charging station, you need to build many, so because charging, you need about at least 30 minutes. So that means it's not 3 minutes. So that means you need to, in theory, you need to build 10 times more charging station in area compared to gasoline station. Because gasoline only takes 3 minutes, charging needs 30 minutes. So that's why the land use will be a big problem for conventional charging. But however, if we go for this kind of dynamic charging, we can eliminate this kind of charging issue. We can more effectively to make use of the land, make use of charging time, because the vehicle can charge anywhere, anytime. But when we say anywhere, it's not really fair, because anywhere means we still need to build many of wireless charging stations everywhere. So that will be a really large investment. And of course, another key advantage is real-time charging. You can charge anywhere, anytime. We can charge continuously while we are driving. So that means we reduce our time to look for the charging station. We reduce our time to recharge our vehicle. We don't need to think about to build up the charging station and wait during the charging. So that's all our advantage about the charging. Another thinking will be in the future, we'll have many autonomous vehicles. When we have all the autonomous vehicles, the autonomous vehicle itself can able to help you to look for which route we have a electric vehicle charging facility. So they will route them so that you can drive along this road to help you the dynamic charging. Then also is environmental benefit. The thing is, if you charge and discharge, one cycle will damage your lifetime. But if you always use continuous charging, then you always can keep your charging within the most beneficial region of your SOC of your vehicle. That means once you do dynamic charging, you always maintain your vehicle within 20 to 80%. Sometimes you maintain between 30% to 70%. That's even better for your battery. The best way to maintain a battery with 30% to 70%. Using this kind of autonomous vehicle, this kind of the MAC method, move and charge, you can always maintain the SOC range within that. You can really prolong your vehicle probably to beyond 5,000 cycles, right? So that's a good. So in a way, if able to extend the lifetime for the battery, then that means we can able to reduce the battery and waste. That will be really good for the environment. Then for commercial vehicle, because they need to think about how to deliver their product, deliver their delivery. In this case, if they're able to use this kind of dynamic charging, they don't need to worry about how to schedule their vehicle. Their vehicle can be able to done really much easier for them to schedule their timing, delivery, operation, because they don't need to allocate 1 hour, maybe 2 hours within a day to charge the vehicle. I think in the future, all the vehicle probably will go for electric. Then you can see that if the bus or the Uber or maybe the other delivery vehicle, then they need to allocate 1 hour, 2 hours for charging, that will really affecting their operation. So that means if they're able to use this kind of dynamic charging, they don't need to worry about it. They just use an autonomous vehicle program to make sure the vehicle will drive along this kind of MAC route. That will do. So that's another major development for infrastructure system. So you can see that once we use this kind of EV infrastructure, many things will be changed, including battery swapping, including dynamic charging. That were two major things that will affect the whole structure. So let's review all the major disadvantages. Firstly, it's really expensive to implement the wireless charging power system. I think you know that. I think we got a 2-coil, transmitter coil, receiver coil, inverter. Also, the receiver all have additional power electronics. We also mentioned about EMI protection. You see, when you want to have higher power charging, the power magnetic field you need to inject in the coil must be really high. So in this case, there must be not the leakage field. The 2 coils are separated by at least 15 centimeters. So there's a lot of leakage field in all the sides in the circumference around the coil. At the moment, all the research papers have been taught about the efficiency, performance, but they seldom touch too much on the EMI issue. You can see that if you look into a coil, then you can sketch to you how the field should look like. If you've got a coil as such here, you got another receiver coil in such a here. Then the field actually will go through here. Then the problem is all the magnetic field, we do need to have return path. So this return path, all these are air. So return path can only receive through the air. So you can see that if that is the ground, so here, that is the EV. So between them, there will allow the leakage field in 3D manner, because the return path can only return through the air, not through any flare line, not through any coil or wire. So that means if you have here, all surrounding will be leakage field. All the field must return through the air. So you can see that if I have so many coil on the road, the whole road here Then you can see that you got a coil in here, you have many coil in here. Then you can see that everywhere will be EMI. So that could be very disturbing. We're not quite sure if all the highway, all the road, all the city, if all of the coil, what will happen. Another technology we are thinking will be using two wire. To do that, they jam your high magnetic field in here. To do that, they only lay out one cable or two cable. So the cable will produce the EMI. So this will be much lower cost. When we lay the cable, make the coil like this will be really expensive. But when we're using this one, one side they can produce high frequency coil in here for this location. Then they can reduce some of the coil. So there's many design as such. Multiple coil will be more common method for design, but people are using two-wire method to design the EMI. But that could be something feasible, but the power field come out, power magnetic field come out may not be that high. So but it's much cheaper, low cost to implement the upper one. So there's many issues to do that. Mainly about the EMI issue, not quite sure how to design them properly. Another issue about the international standard. We don't have any international standard. We have something related to stationary. Stationary, that means in the parking lot, we have good standard how to control them. But for move and charge, we don't have any recognized, well-accepted standard because that's still under development. We're not quite sure how to do that. Then we also need to unify many manufacturers. The thing is that coil is to implement inside the vehicle. The manufacturer need to accept that technology. Like our phone today, we take quite a few years for the phone company to install the coil inside for the wireless power charging. So this need all the manufacturer to agree with certain standard. Because all the vehicle have different design. If you put coil there, that may influence the battery, influence the circuit, influence the computer there. The field is very strong. We're talking about the field could be up level or fraction of Tesla field. So that's quite a strong field. And the field will be with high frequency, talking about hundreds of kilohertz or maybe tens of kilohertz. So there's a lot of the facility in there. At the moment, we don't have any space to install the wireless charging network. So we need to reconfigure how to reorganize our underground facility. So that means even though we do that, even though we put the coil at the top, we don't care. We just build the road on the top, build the coil on the top. But underneath, there's a lot of the piping, power line, all these things will be influenced to each other. We're not quite sure how to make them safe because this is a new system. But however, the internet system, Wi-Fi system underneath, the gas pipe system, electrical power system, they are old system. They don't have any standard related to high frequency kilohertz. So that means some new standard need to be investigated. So I think we stop here because we're close to 3:20. So next week we examine more about the payment system, how the infrastructure shall look like. Any question up to this point? No. So I will upload it to my channel. So if you, in case you like to see the review of the lecture, you can go to them. So next week we are going to have the quiz, the second quiz. I think I already post them next Thursday, but we'll continue this in next Tuesday. And then the quiz will cover everything from last quiz until this lecture. And until
Just as one question?
no, I haven't finished that.
Oh.
Totally will be 30 points like last time, but I'm going to set more questions during the weekend. Yeah, similar to last time, some short questions, some multiple choice.
Oh, small.
Okay, so that will be in person, open book, open looks, open in internet, open everything. Okay.
I thought it was an essay question this time. Because
No. I just
quiz
prepare
is one
the
question.
information for it to understand. There will be a quiz next Thursday. Okay. So see you again then.